We are a part of the IMSE program at Iowa State University, and this is our capstone project on quality assurance and decreased material handling.
Our team has been dealing with three main problems over the course of the semester. These problems include quality issues with mats on the product that have been arriving to customers out of dimension, unnecessary material handling of liners, and lastly, addressing an issue with operators rolling mats by hand, which has resulted in serious ergonomic issues. The objective for the first problem is to reduce the defective mats caused by shrinkage and poor initial cuts by 50%. We also plan to improve the direct feed of liners to assembly line 1 by relocating the cutting process, and we plan to select a new automated machine to reduce the RULA ergonomic risk.
Now we will take a look at the shrinkage rates between the suppliers. Samples were gathered and monitored over a 2-week time period for Supplier 1. Here you can see control charts our team constructed to represent the shrinkage rates. You can see that Supplier 1 consistently shrinks out of tolerance. The same process was performed for the material supplier, Supplier 2. The supplier was able to stay within the tolerance zone. At the end of the test, Supplier 1 had a shrinkage rate of 0.26% and Supplier 2 had a shrinkage rate of 0.18%. Now Logan will be taking a look at cutting accuracy for initial cuts.
The second defect is an issue with initial cut dimensions being out of tolerance before shrinkage. To quantify this problem, our team collected 100 data samples of mats initially after they had been cut from both suppliers. For Supplier 1, a total of 6 mats were below the tolerance zone and a total of 12 mats were above. For Supplier 2, we measured two different model types of mats. The first model contained 53 samples, and the second model contained 47 samples. In total, there were 8 mats below the critical tolerance zone and 14 mats above the critical tolerance zone. We conducted a t-test to determine if the relationship between the two suppliers is statistically different. After conducting the t-test, it was determined that the p-value for the data sample was 0.332. Therefore, it was concluded that the type of supplier does not have a significant impact on eliminating poor initial cuts. We conducted a Tukey test to determine whether Supplier 1's raw material rolls have an impact on the process. After conducting the Tukey test, it was concluded that each Supplier 1 roll received the same letter grade of an A. Therefore, there is not enough evidence to support that the different Supplier 1 rolls have an impact on the process.
The matrix evaluates whether the materials 1. Shrink, 2. Meet tolerance off the initial cut, and 3. Are uniform in mat thickness and have consistently wound rolls. Neither material is perfect, so we suggest conducting a shrinkage test and 100 pass-fail test for the initial cut on the new PVC material to see if it makes for a better alternative. The cutting machines are currently located away from assembly line 1 in the top right corner. Water spiders transport mats and liners between the cutting area and assembly. Product is shrink wrapped both at assembly and the cutting area. Our team conducted time studies to determine the cycle times with shrink wrap and material handling, with shrink wrap and without shrink wrap. Without shrink wrapping and material handling produces the highest liner throughput at 28.9 sets per hour. The water spider currently makes trips back and forth from the cutting area to the assembly line. Moving one of the cutting tables from the cutting area to the assembly line, seen by the yellow arrow, completely eliminates the need for material handling. In the future, the cutting machine will be located at assembly line 1. This change saves 1 hour per shift for water spiders and eliminates 1 shrink wrapping machine.
For the final objective of our project, the company wanted us to take a look at the ergonomics of the mat rolling process. Currently, an operator rolls each mat by hand. A RULA analysis was performed to test the current state and resulted in an average score of 7+. This score requires intervention. The solution our team proposed is to purchase the Inwatec Vortex rolling machine. This machine costs $25,500. By purchasing this machine, the company will eliminate all ergonomic risk and any potential risk for company payouts. Now Logan will be discussing ergonomic opportunity.
By implementing a new machine to roll the mats automatically, this will reduce the RULA score of the process and eliminate all risks involved. Additionally, each objective the team addressed will theoretically result in a positive financial opportunity, as you can see in the listed bulleted points.
Shown here are the budgetary values our group has assigned to each aspect. Installation of the cutting table in assembly line 1 will cost $10,000. The purchase of an automated rolling machine will cost $25,500, which gives a total of $35,500. From the stated budget, we calculated a yearly ROI to be around $26,640, which gives this project a payback period of just over a year and a half.